In Concept F, we're going to be focusing on what's called the ground state and excited states in terms of our electrons, and also discussing how a bright line spectrum is produced. So students should be able to distinguish between ground state and excited state electron configurations. They should be able to write and interpret them, and also, again, be able to describe how a bright line spectrum or light is produced from an atom. So a little bit of review, we mentioned this back in Concept A, that Bohr observed light given off when several elements were heated. And he gave off different colors of light, and he could see this by breaking up the light by a prism and seeing a series of lines. And he found that each element had its own spectra, series of colored lines, wavelengths, and this means that the electron levels of different elements have different amounts of energy. So those different energy levels we name as the first energy level, the second, third, and fourth, and so on, and they surround the nucleus of the atom in distinct amounts of energy. The first energy level is the lowest amount of energy and it's closest to the nucleus, and as you move further and further away from the nucleus, they become higher in energy, and again their distance increases from the central nucleus. So the greater the distance from the nucleus, the greater the energy of the electron. So an atom, which remember atom means neutral, can be in different energy states depending on the positions of its electrons. The ground state means that all the atom's electrons are occupying the lowest energy configuration possible. And this is the configuration that you find on the periodic table. The excited state, however, is when the atom's electrons are occupying higher energy levels. So those electrons have gained energy and jumped to a higher energy level. These excited state configurations can't be found anywhere on the periodic table. So if I look at neon and I look at the periodic table, the 2-8 configuration is on the periodic table. So that's our ground state electron configuration. And as you can see, an electron is moved from the second energy level up to the third energy level. So this is the excited state electron configuration. So we can use the periodic table to distinguish and determine ground state and excited state configurations. So aluminum, if I look it up on the periodic table, is 283. So a possible excited state could be something like 274, where one from the second energy level has gone up to the third, or one from the third has gone up to the fourth, represented by the 2821. I just have to make sure that, and remember that from our previous lesson, the first energy level holds 2, and the second energy level holds up to 8. So I can't go above those maximum numbers. So just kind of keep that in mind, and we'll come back to that when we get to potassium. Boron has a configuration of 2-3. So I could have a possible excited state configuration of 1-4 or 2-2-1. As you can see, I still have the same total. The ground state started with 5. I have to make sure my excited state also has a total or sum of 5. So I'm just moving them. I'm not adding or taking away. And finally, with potassium 2881, I could have something like 2872. And again, I've moved it from the third energy level and it's gone up to the fourth. And there's a lot of other options for excited state configurations. However, again, one that wouldn't be possible is if I had moved it from the first to the second, because then I would have gone over the maximum number of electrons. Okay, so just some ideas of some excited state configurations. These ones cannot be found on the periodic table. So now actually talking about how these bright line spectrums are produced. When we talk about this, we're talking about the electromagnetic spectrum, and you can see the different wavelengths, and you should recognize some of these terms like radio waves and microwaves. The visible one sits right towards the middle, and this is our visible light section, and different colors going from red to indigo and violet have different wavelengths, and these amounts of energies of each of these is going to correspond to different jumps between the electron energy levels. So how are these bright line spectrums produced? Well, electrons can absorb or emit specific amounts of energy by changing energy levels. When a ground state electrons absorb energy, which is considered a photon of light, they jump up to a higher energy level or to the excited state. Now this is unstable and it's a temporary condition. So what happens, and this is just kind of a little diagram, we have an electron that's gained a photon of light, it's absorbed it and jumped up to a higher energy level. Now, like we said, this is unstable. So those unstable electrons are going to rapidly fall back down or drop to a lower energy level. When the excited electrons fall from the excited to the lower energy level, they're going to emit or give off energy in the form of light. So here, this electron, which was unstable, is going to give off a wavelength or photon of light and return to a lower energy level. So just to review, when we go from the ground to the excited state, energy is absorbed, so we say that a dark line spectrum is produced. So these wavelengths of light are the wavelengths that the hydrogen electrons are absorbing in order to go up to the excited state. And again, these dark lines show the specific wavelengths that are being absorbed as the electrons become excited. Now remember, this is unstable, so when the electrons go from the excited back down to the ground state, energy is released, and this bright line spectrum is produced. So the same wavelengths that were absorbed are now getting released by the electrons, and we can see it by the different colors of light and wavelengths on a emission spectrum. So the bright lines again show the specific wavelengths of light being emitted by the electrons as they fall back down to a lower energy level. Now each different drop in energy levels gives off light with different amounts of energy. So these bright line spectrums are unique to a particular type of elements. We can use them to actually identify elements. So we can identify them by, of elements in a mixture, such as looking at the light that's coming from stars, and we can use that to figure out what elements are in that mixture of gases. So every line of an element spectrum has to be present in the mixture. If just one of those wavelength lines are missing, then that element isn't in the mixture. So as you can see, we have 4 different given elements, and we have 2 mixtures of different spectra for mixture A and B. So you want to check and see, you'll see that sodium, which just has these 2 distinct wavelines, those both are contained in spectra A, along with lithium has these 2 over towards the right, which match up exactly with what is in mixture A. So that means that sodium and lithium are in mixture A. Mixture B, you'll see that hydrogen, it's 6 wavelengths are contained in the mixture B, and we also have, back to lithium, these 2 in the mixture. Okay, so that means that hydrogen and lithium are in mixture B. And again, every single line has to be contained. Helium looks like it could have this wavelength right here in the mixture, but I can already see that this one is not present, so helium can't be in there. Because again, every single line, which represents a wavelength, has to be in the mixture. All right, so here's just some quick practice problems for you to try out, some multiple choice. So practice 1, which of the following is in the excited state electron configuration? Well, if you look at your periodic table, A, B, and D you can find on the periodic table. So that means C is our excited state configuration. We can also notice that normally this one electron would have gone down into the second energy level because it's not full yet. So another way to spot it. This is comparing the third shell to the first shell of the same atom. So you want to look through and determine which one of these statements matches up. Now, we know that the third shell has more energy, and we know that it's farther from the nucleus. So because of that, choice B is the correct answer. All right, a bright line spectrum is produced by, remember, bright line spectrums have to come from energy being emitted, and this happens when the electrons fall back down to the ground state, so choice A. And then finally, based on the bright line spectra produced by the 4 gases below, which gases are present in the unknown mixture. Okay, if you take a second, check this out. You should find that gas A and D are both contained in the mixture because every single one of their wavelengths is found in the mixture. Okay, that's it. So we're going to go back over again tomorrow, ground state versus excited state, discuss all the types of questions and content that's related to that, and then also practice explaining how these bright line spectra are produced.